Okay, review time of an LED light bulb called the Enviro-Bulb. This one came off of Amazon. It's a 60 watt equivalency, 850 lumens, 11.6 watts, packaged in a very unremarkable brown box. What catches one's eye actually is the shape of the bulb. It's quite unusual, and it has what appears to be like fin-like structures, and there's an optical, almost looks like a lensing going on here. So that caught my eye, so I thought I would take a deep look at the optics on this bulb. Okay, so what makes this bulb unique is it's there's these three panels here, and they have this micro lens structure. I'll zoom into that in a moment. And then most unusually, actually, these whole array will actually come off the bulb, and you can look downwards, and of course the yellow dots are the light emitting diodes. So a very unique construction. The LEDs firing upwards, and then these little micro lenses taking the light and of course causing it to go out on the sides. One thing you notice actually with the assembly right off the top of the bat as well is the center component. I was sort of expecting that might be a capacitor that you might put there so it achieves the best amount of cooling. However, that's actually a large power inductor, this component right here. So, okay, so here's a real zoom in of the array. You can see the striations there appear to be sort of a lens-like structure. I'm not sure about the occasional striations, whether these gaps are on purpose or if they're having some manufacturing difficulties keeping the striations consistent over the array, because they seem to appear almost in a random-like pattern. Okay, let's talk about the light output pattern of the bulb. That's fairly important. LED bulbs are all over the map in terms of their ability to emulate an old incandescent bulb, which is important because when you're replacing an incandescent with an LED, you want the light fixture, I should imagine, to look the same. This is a polargraph, obviously, and I record the light intensity at various angles of the light meter to get some sense of the light output. And that results in a polargraph that looks like this. Now, this is actually the most unusual polargraph I've done in quite some time. It's a very poor emulation of an incandescent light bulb. The lobe pattern looks very strange. In fact, I just redid the measurements twice just to reconfirm, and it remained fairly unusual. Now, fortunately, this vendor also has this data on their website. They actually produce a data sheet, and it tends to confirm the pattern being fairly unusual. It's the blue line here. It's almost like a star configuration. The two red dots are basically showing that the bulb actually meets the energy star, which is good. But this pattern is very unusual, and it's very unlike an incandescent light bulb. So I would imagine that this light bulb in some fixtures would give fairly different results. Okay, so when I open the bulb up, there's a little piece of paper inside of it, and there's the word Rambus. Rambus is a company. They're more well known for their intellectual property, basically purchase patents and then use those patents to pursue people who might be infringing upon them and achieve fairly significant revenues by doing that. So, and in fact, when I pull up the data sheet, it's also marked Rambus. So it looks like this company's moving in from, they traditionally were in the memory space, actually. It looks like they've obviously branched out here and are pursuing the patents in the very rich area of LED light bulbs. If you pop up the website here, you can see, of course, a long listing of patents, and most of them appear to be patents they have purchased. They were originally assigned to different companies. So, no surprise, really. LED light bulbs is an area of really rapid evolution, and the lighting market actually is really large. So, anyone who can secure a keystone patent in this area, of course, would achieve a fairly hefty revenue stream on those patents. So, very interesting. Okay, let's talk about flicker. Obviously the bulb here in the lower part of the frame and a solar cell mounted on a jig on this part of the frame. I always normalize the light falling onto the solar cell to be 450 lux, and then I look at the output of my oscilloscope, which gives me a sense of how much flicker each bulb has. In this case, you can see it's recording about 210 millivolts peak-to-peak flicker. It's of course the absolute number that is of importance, and here we compare it to the other bulbs. You can see this one is falling into the upper high range from the ones I've looked at so far. So if you're wondering if flicker is a problem, here's a very good example. I got my camera just at the light bulb, and you can see these black bands are rolling by. Now those bands you can't actually see. What's happening is the shutter of the camera is slightly out of step with the light output of the bulb, and you're getting a beat frequency there. But this is the problem, of course, in movie making. LED light bulbs, you have to be very careful to make sure you purchase ones which have no flicker, otherwise you end up with this banding on your movies. Okay, let's talk power consumption. The datasheet says 11.6. You can see my watt-hour meter is reading considerably higher, 13.0. And I actually let it run for a bit. Sometimes bulbs get a little bit better as they get warmer, but this one is, yeah, this one's way off its data. Okay, well, that was very interesting. The micro lens structure definitely gives a way of distributing light from these planar LEDs. I haven't seen this particular structure before. And I guess that's what's really interesting about the LED market right now. There's still a lot of innovation. The bulbs all are engineered differently. Quite frankly, though, I think there's better emulations of this pattern out there. Some of the Philips bulbs with their remote phosphors are especially good.